Let me start out by saying hello and welcome. I'm Teresa Gibson. If you haven't had the chance to meet me yet, I'm really honored to be able to meet you and to be able to host our session this afternoon. Congratulations to all of the state finalists for making it to the state level fair. It's quite an impressive accomplishment. And we're so glad that you were able to join us. Really excited about those of you who were able to sign up to share your research publicly. I will be recording today. And so we will take these recordings, get them up on our YouTube channel, and you will be able to point to them. So if your family, friends, etc., teachers aren't able to jump on live with us today, you will have this recording. You can even include it, point to it in a portfolio for those college applications. So I will make these publicly available so that you can refer back to these sessions to show your research. All right, and so with that, I am going to get us rolling kind of with how the session will run. And so thinking about courtesy for each other, I have given you all full permission to mute and unmute. And I'm going, because I want you to be able to pass the microphone to your colleague or your peer as your part wraps up, I'm just going to ask you to please stay muted unless you're the presenter. That will be our first piece of courtesy. Please respect the timer. Because I'm allowing you to share your screen, you won't be able to see my timer, but I will drop into the chat when there are 30 seconds left in your 2 minutes. I will start the timer once I have officially passed the mic to you. And so while I introduce the project, that's the time for you, if you want to unmute, get settled, give me a thumbs up that you are ready. That will be your time before the timer starts, and then you'll get 2 minutes. That's why you saw on the schedule, I left approximately 3 minutes for each project team. So respecting the timer, watch the chat for me, but also cheer each other on. This is like your big fair presentation. This is what we would have done in the afternoon for public viewing. And we want you all to tell each other how amazing the work is. And so you can cheer in the chat with text, or you can use the reactions to cheer each other along and celebrate all the amazing research. And I'm also going to encourage you to ask good questions. Part of the judging experience is to get great questions from professional scientists and engineers and mathematicians as you go through your project, but also getting great questions from your peers is a great way to learn and to think about your research from another perspective. And so please do actively use the chat. We want your voices to be part of this process. All right. How will we pass the mic? Each time when the timer is done, I will steal your screen and post the title of the next project. That time when I'm introducing the project is the next project team's time to shift their microphone off of mute. The project team that's finishing up, stop sharing your screen, shift the microphone off. If you're not sharing your screen, that's fine. Sharing your screen is totally optional. But I wanted you to have that. The 30-second warning will pop up in the chat. And so when I pull the screen back up and I'm passing the mic, your job is to stop screen sharing and mute. If you are the person whose project I'm introducing, that's your opportunity to unmute yourself. And if you plan to share your screen, you will be able to do that as soon as I stop sharing. It won't let you steal it from me. So before we just jump into project number 1, I want to make sure that there are no questions. So if you have questions, go ahead, drop them in the chat now. You are welcome to, you can direct message me or you can message everybody. Just make sure if you direct message me, you switch back to everyone so that you can cheer each other on and ask questions. Yeah, and so attending both sessions, we do want you to attend both sessions, and we appreciate you coming to present, but we also want you to be there to present and cheer along your peers. For the second session, we will take a break in between, so you all can, get some food or whatever you need to do in between. But we do welcome you, and I will give you the start time for the second session right at the end of this one. So thank you for asking. If you have 2 people on a team, I have the microphone set, or the Zoom room set, so that it should follow the person speaking. And so if you both unmute and you know when each of you is going to speak, then it should follow automatically to the speaker. So that's how I have the Zoom room set. you all do have control over who you're seeing. You can put it in gallery mode or speaker mode. And so that is up to you if you want to toggle that, but the default setting is so that you will see the person speaking. Do we have any other questions before we jump in? Just going to give you a minute. All right. And so with that, we are going to invite our first speaker up to the mic. Our first speaker is going to speak, Cheyenne Rogers, Bio B, going to speak about I'm Fine, her project on mental health of students during COVID. And so with that, we're going to pause and I'm going to let you capture the mic, Cheyenne. I saw you in here.
Yeah, can I go ahead and share my screen?
You may.
Okay. And if you can give me just a thumbs up if you can see it.
It's pulling up. It's taking a second.
Am I
There
good?
it is. Yes, ma'am.
Okay.
All right, I will start your timer.
Hi, everyone. My name is Cheyenne, and for my project, it's titled I'm Fine, and I looked at the mental health of students during COVID. I'm not going to detail all of the research on mental health, but it does have a long history. Something I do want to talk about are suicide rates during a pandemic, which have went up. They have been on the increase by 20% on the United States since 1999. And there's a graph right there that you can see that just proves my point. So the purpose of this is to see how being in a pandemic has affected the mental health of middle school and high school students. And my hypothesis was that there would be a noticeable change in our mental health. So what I did was I created an anonymous Google form that consisted of 39 questions. The first 18 questions were asking about their mental health before COVID. The following 18 asked about their mental health after, so I could just see the difference. And I waited 4 days for everyone to respond. So I'm going to highlight the graphs right here. As you can see that 35.1% of my participants said that they had no issues with their mental health before the pandemic. But then people said that they started to have trouble with their mental health, which rose to 42.1%. People said that only 29.2% of people said that they had struggled with depression before COVID had hit, which rose to 36.3% after COVID. Anxiety rates went up from 39.8% before COVID to almost 55% after COVID. This is something that I really wanted to highlight. People said that they had suicidal thoughts or feelings before COVID, which was only 15.2%, which had risen to 22.2%. People said that they had actually acted on these thoughts, which had risen by almost 7 total percent. And people had said that their mental health was actually negatively affecting their grades at school from 22.8% to 38.6%. And we can just see here how it has risen from 46.2% of people being overly worried about the future has risen to almost 60%, which is completely understandable. 31.6% of people said that they were overly emotional, which had risen to almost 45% after. And this is just another graph that is looking at suicide trends. So basically what we can conclude from all of this research, which I won't go into total detail just for time's sake, but we can see how our mental health has been affected while being in a pandemic. And we actually won't know until 2 or more years from now if our suicide rates actually went up during this time because of just the little research that is going on to prevent that. And what we can draw from this is that we just really need to be able to have those open conversations with our parents and our peers and just people around us who may say, well, I'm fine, like, don't worry about me, when actually they're just hiding a lot of emotions. And there's nothing wrong with mental health. We just have to get rid of the stigma that is around mental health. And we just have to be able to have those open and honest and genuine conversations with ourselves and with people around us. And like I say, there are two types of people with this, types of people that will notice their mental health and will say, I need to get help, instead of taking out these thoughts in a bad way, such as suicide and self-harm, when we need to take out these thoughts in a positive way by seeking help and just talking out our feelings, or seeing a therapist or a doctor, anything that can help you. There's also lots of free websites or anything like that that can just help you, and just be sure that you get the help that you need. And I'll pass the mic on to our next person. So thank you, everybody.
Thank you, Cheyenne. Yes, and participant just let me know that it is sometimes difficult when you're the speaker to see the chat. And so I can jump on and say 30 seconds if that's not too disruptive for you all. So I apologize. I thought you'd be able to see it, but thank you, Cheyenne. That was great research summary and a lot of really important and relevant information in that study. All right, so our next up team, you can work on unmuting yourself, or it is Parth Tara, and you can correct if I said your last name wrong, or
No,
your first
fine.
name. Yes, that's correct. Okay, so welcome, and we are going to hear about a dynamic model of the topological evolution of covert networks. And so with that, I will pass it to you.
Okay, so just let me know if you can see that.
We can.
All right.
Yes.
So essentially, my research focuses on trying to understand terrorist networks and mathematically. So terrorist networks are very difficult to understand just because there's such little information available on them openly in either research or data sets. And that's partially because of the inherent secretive nature of these networks. So my research tries to combat both of these issues. My research tries to develop some sort of robust topological evolutionary model of generating stochastically random covert networks, so we can actually generate those data sets for other research purposes. And it also allows us to understand the theoretical background of these networks. So essentially, my research is just about making a mathematical model of terrorist networks. So my framework essentially outlines some characteristics that I defined in terrorist networks that were quantitative in nature, that I could analyze my model to determine if my model is actually a good representation of real world covert networks. So I analyzed 11 actual covert networks that I could find. The one on the top left here is the Al-Qaeda terrorist network that I found off of the John Day and Artis transnational terrorism database. And I found 30 analytical characteristics that were all statistically significant. And I compared my mathematical model to it over the whole parameter space and determined that essentially all of them fit the 3 characteristics very well. And because of that, my model is an accurate mapping of these actual covert networks. So there's a lot of applications of this research. We can use it to generate data sets for actual covert network research in the future. We can make graph-based deep learning algorithms for link prediction and node classification. And those kinds of algorithms have a very practical application in real-world counterterrorism tasks.
Parth, you have 30 seconds.
Yeah, and we can also use these networks, we can also use this model to essentially predict the temporal evolution of a specific covert network. So there's a lot of applications of this research, especially in counterterrorism. And hopefully by furthering this field, we can actually start to save lives using this sort of theory.
Wonderful, thank you so much. That is like research after my heart. My field is mathematics, and so I love to see a great modeling project presented. Love it. Thank you, Parth. And I don't know if I mentioned this at the beginning. I just wanted to make sure that you all know the chat is open, and most of our speakers will be able to stay on. A couple will have to pop out for their judging interviews. And so if you have questions for these speakers, I am sure they'd be happy to answer them in the chat following. All right, so our next project is a novel analysis of economic development versus carbon dioxide emissions for empirical proof of the Kuznets curve and insights into future trends. And so I am going to pass the mic. We're all set. You ready?
Yeah, can you see my screen and hear me?
Yes.
Okay, so this project was divided into 3 phases. Phase A tested if there was a significant relationship between global economic development and environmental degradation. as modeled by per capita GNI and CO2 emissions in approximately 200 countries from 2009. Phase B compared the model to a future year to determine if it was capable of predicting trends, and Phase C tested if there was a significant relationship between global cumulative per capita CO2 emissions and CO2 emissions from the industries transport, manufacturing, electricity and heat, and residential. So the first part of Phase A disproved conventional hypotheses surrounding the relationship between economic development and environmental degradation, and showed that it followed the environmental Kuznets curve, which suggests that as income rises, environmental degradation rises, peaks, and falls. Thus, investment into lower income countries could accelerate them through this process and reduce environmental impact. The important takeaway from Phase B was that the EKC established previously could be used to predict future trends, and by examining the model and observing its properties, I was able to derive a function that located the exact countries where additional dollar increases to GNI have the most associated change in emissions, and ultimately I concluded that the most valuable returns come from prioritizing investing in regulations that improve the per capita GNI in lower income developing countries. And from Phase C,
You're at 30 seconds.
okay. And from Phase C, I noticed, well, actually, I'll just skip that part and go to the end. So overall, these phases can be combined into one final conclusion: investing in better electricity and heat generation technologies, improving human and physical capital in the residential space, and promoting taxes and deregulation policy with market-oriented economic context in countries in lower income developing countries is the most efficient plan of action for international funds and agencies with green initiatives like the OECD, United Nations, or World Economic Forum.
Great, thank you so much. And that was perfectly timed. Wonderful. And so what we're gonna do now is pass the mic. I am going to just check in on our next project, the novel machine learning and robotics-based approach to extend the lifespan of Martian rovers. I don't see our researchers in the participant group, but there's a couple of people whose name I don't see displayed. So I just want to verbally check to see if they are here. All right, and so we will bring them back up if they're able to jump in from their judging to do this, which moves us to assessing the resistance of, oh wow, Saccharomyces. I don't know what that is. You're gonna have to teach me, Reba. You're definitely gonna have to teach me that word. To UV radiations. This is a BioA project. And so I will pass the mic to Reba, who can probably pronounce that.
Okay, can you see my screen?
It's pulling up. Sometimes it takes a second. Yes, we can.
Okay. So my project basically observed the effects of UV radiation on Baker's yeast cells. That's what Saccharomyces cerevisiae is. And the inspiration for my project came during the COVID-19 pandemic, when the president and health experts were advising people to go outdoors in order to produce vitamin D, which would in turn boost their immune system. However, the American Academy of Dermatology recommends that people wear sunscreen anytime they go outdoors. This raises a problem since sunscreen prevents the skin from producing vitamin D. So this made me wonder, how long can humans stay outdoors without sustaining sun damage? This experiment used Baker's yeast cells instead of human cells, since they closely resemble each other. So I started off my experiment by creating a large mass of yeast. Then I performed serial dilutions on it, and I created concentrations of 1 to 10, 1 to 100, and 1 to 1,000. From that, I isolated one sample from each of the concentration groups and kept it as a control. And with the rest of the samples, I basically exposed them to sunlight for durations of 10, 30, and 60 minutes. And after that, I took them inside and I allowed them to grow, and they created these colonies. This is only one group. I created 3 groups of them. And then from my results, I was able to conclude that the number of yeast cells on the unprotected samples were lesser than the number of yeast cells on the protected samples. And the number of yeast cells on the unprotected samples basically had lesser colonies as time went on.
Reba, you're at 30 seconds.
Oh, Although I saw promising trends, which could maybe mean that humans can stay outdoors for shorter durations, unprotected, I'll need to repeat this experiment for, again, in the summertime, maybe, to see if I get similar results.
Wonderful. Thank you so much for sharing. And so I will pass the mic. Our next project that's up is an illuminating investigation testing the level of chemiluminescence in synthetic blood when sprayed with luminol solution of different oxidizers. And so I do think I see Chrysalin on, and so I will pass you the mic.
Share screen. Okay, can you see the screen?
And now we can. Yes.
Okay.
Go right ahead.
Okay. Hi, my name is Chrysalin Hygard, and this is my project, An Illuminating Investigation. When forensic scientists examine a crime scene, they first photograph the entire room, then they take items away to test them in a lab, and then finally they spray with luminol. Luminol is a chemical compound that when mixed with the right oxidizers causes blood to emit a chemiluminescent glow. And I believe I tested this my research question, which oxidizer is the most effective for forensic scientists to use with luminol when trying to spot bleached blood at a crime scene, by creating luminol solutions with the oxidizers artemisinin, sodium perborate, hydrogen peroxide, sodium hypochlorite, and potassium hydroxide. I built a fume hood because I couldn't get access to a lab, and I bleached circles of white fabric with synthetic blood and sprayed it with my different solutions. Then I used this Google Science Journal app on my phone and recorded the levels of light that the blood emitted, so I could compare them to my control of the bleached blood with no solution. Instead of artemisinin being the most effective, even though it had the most oxygen, sodium perborate was actually the most effective, as it lasted 151 times longer than the second most effective oxidizer, potassium hydroxide. And so when I found that hydrogen peroxide was not the most effective, I was surprised because it's the most commonly used. But in fact, sodium perborate should be the most effective, is the most effective and should be used by forensic scientists.
You're at 30 seconds.
So I found, after finding that, I also learned that potassium hydroxide is while it's the second most effective, needs to be hot and freshly mixed in order to be effective with the chemiluminescent glow. And so it has to be freshly mixed because it creates the chemical reaction that is really hot. And when that's done, you can use that, and it creates a reaction that's a couple seconds rather than a few minutes, that's like sodium perborate did.
Oh, great. Thank you so much. I love that you discovered we use something that's not the most effective thing.
Thank you.
That's wonderful. All right, so I will work to pass the mic. And next up, I did not see our researcher in the room, but I do want to give Jaden the opportunity, if he's here and I just don't see him, to speak up. Okay, we're going to move then to Chase Chandler, assessing the effectiveness of extracts isolated from Hericium erinaceus as, oh wow, acetylcholinesterase inhibitor. Oh, I do know that word. All right, Chase, put me to shame. I'm passing the mic.
Yep. Oh, there. Alrighty, my name is Chase Chandler and I attend the North Carolina School of Science and Mathematics. My project is on assessing the effectiveness of Hericium erinaceus extract as an acetylcholine esterase inhibitor. Alzheimer's disease, or AD, is a neurodegenerative disorder that is characterized by the loss of motor and cognitive function. There are multiple hypotheses that explain how this is caused, but my project will focus on the amyloid beta theory. Previous research studies demonstrate that low levels of the neurotransmitter acetylcholine is correlated with high levels of the amyloid beta protein. You can increase acetylcholine by inhibiting the enzyme acetylcholine esterase. I chose to focus on Hericium erinaceus because this fungus has indole alkaloids that are chemically similar to galantamine, an alkaloid isolated from the plant like Chorus radiata that is actually the current acetylcholine esterase inhibitor. I've conducted 3 main experiments: a pyrolysis assay with high concentrations, a pyrolysis assay with low concentrations, and then an elements assay. All experiments had isopropyl alcohol as my negative control, galantamine as the positive control, and the model organism was wild-type Drosophila. The first experiment of the process assay with high concentration demonstrates that all process curves of galantamine extracts were significantly different to isopropyl alcohol. The second experiment of process assay with low concentrations shows that the two lowest concentrations of the galantamine and extracts actually had no significance to alcohol. The final experiment was to demonstrate whether there was a chemical inhibitory process by utilizing the Edmonds assay, which quantifies acetylcholine esterase concentration using spectrophotometry. My results show that all concentrations of galantamine and the 0.05 grams per milliliter concentration extract significantly decreased the acetylcholine esterase concentration. I conclude that acetylcholine esterase inhibitors in the extract are both toxic at high temperatures, which implies both chemical share characteristics. However, that low concentrations are not toxic, which means it could be used as a therapeutic. Finally, low concentrations of the extract may inhibit acetylcholine esterase, which means it could be used as an acetylcholine esterase inhibitor. Further outlook is in a process assay with flies that express the human amyloid beta 1 through 40, and further experimentation with Edmonds assay in lower concentrations to confirm my final conclusion. Thank you.
Wonderful. Thank you. It was excellent and great timing. I am going to now pass the mic. And so next up is Timothy Campbell, climatic and biogeographic implications of the lower Waccamaw Formation molluscan fauna of the Register Quarry. And so Timothy, if you are ready,
Okay.
I will pass you the mic.
Okay, I can share my screen. Okay. There we go. So my project says what climatic conditions, habitat types, and sea level were present during deposition of the early Pleistocene 2.4 million year old lower Waccamaw Formation based on the molluscan fauna of the Register Quarry in southeastern North Carolina. The higher temperature and sea level in the early Pleistocene provides a model of what types of organisms might be found off the North Carolina coast with anthropogenic climate change, and it shows how different groups of mollusks fared through the environmental changes over the past 2 million years. I hypothesized that the Register Quarry fauna represents a variety of habitats from roughly 40 meters depth to brackish water and represents a warmer climate than today. Prior to starting the project, I had collected extensive samples of lower Waccamaw Formation mollusks from the Register Quarry and had examined other collections. I compared the fauna I found with 8 North Atlantic faunas for which I had reasonably up-to-date, thorough references with depth data. I then researched the habitat and depth preferences of the species found at the Register Quarry or of their closest living relatives. I determined how many species each of the recent faunas shared with my Waccamaw data and compared the number of species in different taxonomic groups of mollusks. I then performed a statistical analysis comparing the species distribution across taxonomic groups of mollusks between the comparison sites and the Register Quarry. The data on shared species and 30 seconds. The data on shared species and diversity show that the Waccamaw fauna is most similar to the modern faunas of South Carolina and North Florida. This indicates a somewhat warmer climate than today. The faunal comparison analysis showed the Waccamaw is rather different from the modern faunas. The habitat data indicates a typical range of habitats for the southeastern United States. The depth ranges would seem to indicate sea levels ranging from somewhat below the site to about 50 meters depth above the site. Factoring in local effects gives peak global sea level as about 45 meters above the current level. My hypothesis was mostly supported.
Great, thank you so much. All right, with that, I'm going to pass the mic. And so who we have up next is Joshua Cupros. I did not see Joshua on the participant list. I just want to pause in case it's just not named correctly, if Joshua is with us. All right, and so with that, we're gonna go to, oops, I apologize, I went to, where's Audrey?
I'm right here.
I apologize. Your project slide's not popping up for me, but Audrey's our last speaker before break, and we have her for junior rowing analytics predicting 2K ergometer times. So I will pass you the mic. I don't know where your slide is, but.
Okay, awesome. So I'm just gonna share my screen. And if you don't mind, do you mind if I time myself so I can just, okay, cool. All right.
Right ahead.
One moment. Can you see my quad chart?
We're actually seeing your presentation.
Okay. Sorry about that. Okay. I'm sorry, just 1 second. Okay, do you see my quad chart now?
Yes.
Awesome. Okay, cool. So I am Audrey Biller and I am a varsity rower. And my project revolves around predicting how long it takes a rower to complete 2,000 meters on an ergometer machine. The erg time is just like the SAT of rowing, so I wanted to predict what my erg time could be in a year to see whether I could actually get into a good rowing program at college. So to do that, I used 24-year erg time data provided by Crashby Sprints, which is a major indoor rowing competition, as you can see in my quadrant 2. And so first I cleaned the data, then I measured if the erg times of a rower of consecutive years were dependent on each other. I found strong positive correlation and observed stronger dependence for the faster rowers. This motivated me to investigate if linear regression models could predict the erg times. When I used both current erg time and target percentile, I found that the linear regression model gave a very good prediction on the lightweight rowers, but not so much the heavyweight rowers. So I instead used the ensemble model to work on the faster, heavier weight rowers. I applied the prediction model actually to my own erg time from last year and saw that the predictions were incredibly close. And I was amazed. So my goal is to make these prediction models available to these junior rowers with the mobile app that I will create during the summer so that they can make their own predictions and their own conclusions. So I'm very passionate about rowing and data science, so I was very excited that I could share my quad chart with you guys today. Thank you.
Great, thank you so much. All right, and so with that, I am going to just share my screen one more time and push us into a quick break. And so what we will do is reconvene right in this room at 1:05, and I will go through a quick intro for the new researchers that will be joining us from judging to share their time. And I will give an opportunity at the end for anybody who was not able to make their time slot to make it up. All right, we are going to get started again. So hopefully that little break got you some stretching in. And we know that we have some new folks to welcome. So welcome to our researchers that are just joining us. We hope that your day in the judging rooms went well and that you are ready to share your research with us. So just for the folks who were not able to be here in the 12 o'clock session, I want to establish a little bit of our researcher courtesy. So we are going to run the room together as a group today. And so our basic rules or norms for courtesy will be I've given you the power to mute and unmute yourself. That's so that you can jump in when we pass the microphone to you to present. But I am going to ask that otherwise you remain muted so that other researchers have a clear presentation with no background noise. And along with that, we are going to also ask that everybody respect the timer. And so each project team will be given their 2 minutes with the microphone. I will jump in verbally at 30 seconds to let you know that you have 30 seconds remaining to conclude your summary. And then we also want you all, we did get into in the first session some good talking back and forth in the chat. We'd love to see more of that. So make sure you not only cheer each other on, but make sure that you're asking good questions as you hear folks' research summary. Good questions are how we get new research and better research. And so we want to always be encouraging those great questions. with our general rules of courtesy, I also just want to give you the run of show. And so I'm Teresa Gibson. I'm the executive director of the FAIR Foundation, and I am going to be hosting. And so my role will be to introduce each project. I will do my best to say some of the chemical names and genus and species that end up on your project titles, but you feel free right after me to jump in and say them correctly so that everybody understands what you're speaking about. Each project will get their 2 minutes with my 30-second warning, and then while I'm presenting my screen, that is the time for you to be passing the microphone as I introduce each new project. The prior team will be muting their microphone and stopping their screen sharing. And then when I'm done introducing the project, I will stop screen sharing and the next team or researcher will get to their 2 minutes to present. Before we jump straight into our next set of summaries, I would love to just give an opportunity. If you have questions, you can drop them into the chat and I can answer them before we get started. All right, wonderful. Well, with that, I will get us rolling. I will introduce our first project for the afternoon. And I skipped a slide. There we go. Our first project is mathematical modeling of the Origami naval shell. And we have a team. And so our team, you can both unmute and just share the microphone. I have it set so that it should shift to whoever's speaking for the rest of the audience to see. And so with that, I will pass it to you.
Okay, let me just share my screen. Can you see it?
Yes.
Okay, yeah.
Okay, so our project falls under the field of mathematical modeling of shapes, and we were especially intrigued by the famous nautilus shell, which is a mollusk with an extremely unique and chambered shell. And this nautilus shell its spiral shape has been extensively modeled by both mathematicians and origamists. However, mathematical models actually disagree because there's so much variability across different nautili. In contrast, origami designs are precisely repeatable, but surprisingly, no mathematical models actually exist for them. So what we did is we took a popular origami spiral that is based on the nautilus shell, the origami naval shell, as you can see here, and we mathematically modeled its shape and then compared it to the nautilus shell. And for this, we did 3 main things, which Gurma can explain.
Yeah, so first we constructed the ideal geometric model for the naval shell by analyzing the folding instructions provided. And this required us to use some geometry and trigonometry to prove some lemmas. And then second, we developed a parametric smooth model to approximate our geometric model by using curve fitting techniques and solving a minimization problem. And this involved using properties of logarithmic spirals and convex functions for designing the problem. And then we wrote a simple Python code to just solve the problem for us. And third, we evaluated the fit of our models against previously proposed models for the nautilus, as well as a different species of the nautilus. And our evaluations were able to confirm and also disprove several commonly held beliefs about this spiral design.
And 30 seconds.
Okay.
Sorry.
Yeah, no problem. So to our knowledge, there are no mathematical models for most origami spirals, and we hope that our success in this research can help develop a formal framework for mapping folding instructions, geometric models, and smooth spirals. And that's it. Thank you.
Great. Thank you so much, ladies. That was really interesting. And now I'm going to have to look up like the origami. The fact that there aren't models for it is surprising to me. So thank you for sharing. All right, and so my role now is to pass the mic, and I will get us to our next research project, Outstanding, which I think is an acronym from uploading the projects, and we're going to introduce Annabelle. Annabelle, I will pass you the mic.
All right, hi. I'm going to share my screen real quick. All right. Can you see it?
Yes.
All right. Hi, my name is Annabelle Hayes, and my project is called Outstanding. What I created was a manually standing wheelchair. I built it for my mom, who could really use this in day to day. She will now be able to do things like cook meals, open cabinets, and wash dishes. Plus, before I researched how to build the chair, I researched if there were any benefits to being able to stand. What I found was that it reduces pressure sores, allows a person to stretch out their muscles, and improves bone density to lower the chance of fractures. I wanted her to have those same benefits. So standing chairs already exist, so why did I go through the trouble of building one? Standing wheelchairs on average start at about $50,000. This is a price that is way too high for a product that isn't seen as a necessity. Companies charge this extreme price for these types of chairs because of the electronic lifts that the chair uses. On top of cost, I also did not like the fact that the chairs were way too heavy to be easily transported, and the majority of them were not able to move once in a standing position. My chair is the only chair that I am aware of that is a lightweight, manually lifting, mobile, manually standing wheelchair. I am hoping to get my wheelchair design patented so it can become an attachment kit that would only cost about $150. I would also like to briefly talk about how my wheelchair works.
Great. Yeah,
I use
30-second mark.
Okay. I use gas lifts to both push my chair into a standing position and hold it down in a sitting position. My inspiration behind using gas lifts is from the trunk of a car. The gas lifts push up and hold the trunk door, and after you start it, my chair works the same way. You have to push yourself upwards to start the chair, but afterwards, the lifts push you the rest of the way upward and support your weight. That's all. Thank you.
Wonderful. Thank you so much. And I will take and pass the mic. So our next project is a team project, and it is the removal of deadwood chestnut trees with local fungi. And with that, I will pass the mic.
I'm going to share my screen. Can you see that?
We can see it. Perfect.
Okay, sweet. I'm Jarek Stewart-Karlowicz. Okay, hold on. My partner's Wi-Fi might be acting up. Sorry.
Oh, that's okay.
I might just have to do it myself. I'm not sure.
I'm sorry. I got my Wi-Fi to work. I'm here.
Oh, perfect. Okay, I'll reset your timer, y'all. You're good to go.
I'm Jarek Stewart-Karlowicz.
I'm Nicole Vargas Sancho.
And our project was on the removal of deadwood chestnut trees with different fungi. So our research question was like, what types of fungi could we use to degrade the deadwood hybrid chestnut trees that were plaguing the forest?
So basically, chestnut trees that are hybrid happen to not be known how they can decompose, and we fear that they might be plastics of the forest. So we decided to test them against different fungi, which are turkey tail, oyster mushroom, and L-tiger's mushroom, to see if they would be decomposed in the environment of North America. So first, we got some wood donated of an American hybrid chestnut tree, the American chestnut and the Chinese chestnut tree. And then we made them into sawdust and put them into water agar plates. And then we put liquid cultures into the plates of the mushroom liquid cultures into the water agar plates with the sawdust. So we could test if it would decompose each type of wood. We then measured each plate for 24 days in the circumference of the mushroom growth.
For our results,
I'll have 30 seconds.
The graphs were scaled by 2 days and 20 millimeters. We couldn't put all the graphs on there, but those are two of our main charts, and they showed pretty promising results. And for our interpretation and conclusions, the wood decaying fungi could decompose the hybrid trees, but they had a harder time decomposing the hybrid trees with more Chinese than American. And our hypothesis was supported. Fungi would be able to decompose hybrid trees, giving the perfect area of growth, and overall turkey tail grew the most efficiently.
Great. Thank you so much. I didn't even know there was a possibility that we would have trouble with something hybrid decomposing. So, thank you. All right. I'm ready to pass the mic, and our next up is Secured School Release System.
Thank you, Mrs. Gibson. I'll share my screen now. Okay. Hello, my name is Aditya Sumarama Krishan, and today I'm proud to present to you my project, the Secure School Release System. Secure School Release System is my solution to address the inefficient and insecure school dismissal systems used in over 90,000 elementary and secondary schools across the country. This impacts over 7.5 million students every single day. I would now like to provide a short demo of my application. Let's begin with the admin tab that is in the middle of this page. The admin can add or remove students from the Student Details tab and add or remove parents from the Parents Details tab. On the right side of the screen is the parent's application. The parent can log in, and if they are within the predefined perimeter, they can activate the pickup. If the parent is outside the predefined perimeter, then they cannot activate the pickup. As the parent activates the pickup, there will be an ordered list on the staff side of the application, which updates itself based on how close the parent is to the pickup zone. As the parents pick up the children, the staff can release the children. The overarching goal when doing this project was to create an application which is efficient, secure, and low cost, so it's accessible to all students in schools, regardless of their zip code. The application was created using Java mobile APIs, Node.js, Google Firebase databases, Google URI tracking software, and geolocation tracking software. The resulting application is efficient, secure, and low cost, and I hope to provide students across the country with an efficient and safe dismissal process. Thank you.
Wonderful. Great. Thank you so much. All right, it's my turn to be passing the mic. And so our next project up is Seeing in a New Light, Adaptive Changes in Osmin Proteins in Antarctic Ice Fish. And so with that, I'll pass the mic to Ella.
Okay. Okay, can you see this?
We can.
Okay. Oh, sorry, let me get the Zoom cameras. Okay. So ice fish are a core component of the Antarctic ecosystem and a critical food source for many species, including humans. So understanding how ice fish have adapted to the extreme Antarctic environment may not only help us understand how biodiversity evolves, but could help us predict the response of the Antarctic food web to threats like overfishing or climate change. In Antarctica, ice fish are not only exposed to extreme cold, but also to shorter wavelengths of light. So, how did the vision of Antarctic ice fish evolve to accommodate this limited light environment? So in the retina of the eye, cone opsins detect different wavelengths of light on the electromagnetic spectrum, and changes in certain amino acid sequences in opsin protein sites can actually shift each opsin's spectral sensitivity to detect shorter or longer wavelengths of light. And so I predicted that in ice fish opsins, tuning sites will be changed to allow them to detect the shorter wavelengths of more abundant in the Antarctic environment. So to test my hypothesis, I retrieved opsin amino acid sequences from 13 species of Antarctic ice fish, as well as non-Antarctic fish species. Then I aligned the sequences of the 3 opsins in all of these species and identified any changes at the tuning sites. So my most significant result was in the short wavelength sensitive opsin SWS2. So in 2 ice fish species, I found an amino acid change expected to shift spectral sensitivity to detect wavelengths about 30 nanometers shorter.
Overall, I found tuning site changes in 2 different opsins in 3 different icefish species, all predicted to shift spectral sensitivity to shorter wavelengths of light.
30 seconds.
And this suggests that some icefish have evolved changes in opsins to adapt their vision to Antarctic light conditions. So basically, my findings can help make predictions about the effects of climate change and biodiversity. And understanding opsin structure and function also has biomedical implications because opsins are being developed in gene therapies for blindness caused by retinal degeneration. So yeah, thank you for your attention.
Great. Thank you so much. Wonderful. And I will pass the mic. All right, up next, we have Subtitle Your Life, a novel way to deal with hearing loss. And this is a team. And so Philippe and Angelique Faith, you can pass the mic to each other freely, and I will stop sharing.
All right, we'll share the screen and we got this. Okay. And can you all see this?
Yes.
All right, great. All right, so hello, thank you very much for listening to us, and we're going to start. So in short, our project aims to produce an inexpensive, viable alternative to hearing aids. As you might know, hearing aids are very expensive, often costing in $1,000 to $3,000 range, and most of them are not covered by insurance.
To solve this problem, we designed and made a smart glass type device that takes in words said by a person, transcribes, and then projects them onto a glass screen in front of the user's eye.
In order to create this device, we used a Raspberry Pi as the computer and the Google Speech Text API in order to transcribe the words in real time with self-correction. To test this device, we had 3 people with ranging stages of hearing loss, and we compared the number of times the question was asked to the control, which is us who have no hearing loss.
Our test results proved the device to be very fast, accurate, and on par with normal hearing performance. We believe that this device could also be used in other circumstances, such as children's learning, as studies have shown that watching TV with subtitles increases a child's reading proficiency at a faster rate, so having subtitles everywhere would prove helpful in learning.
The flexibility of this device is also a big plus. When it comes to the software, the default transcription can be easily changed to a different language with just a change of the language tag present in the code, which can be helpful with translating and learning a new language. A different program entirely can also be uploaded in order to allow the device to have new capabilities such as synchronization with the phone.
On the hardware side of things, because the device is so modular, different accessories can be added to provide a new function to the smart glasses, such as maybe a camera, to record doctor's appointments, to help the elderly with remembering things such as prescriptions and special instructions.
At 30 seconds.
In the future, we want to try out different designs and such in order to improve the device, such as 3D printing a case, which we could not do because frankly we don't have a 3D printer on hand. And overall, we want this device to not only solve the problem of expensive hearing aids, but to also be a platform for other uses and to grow the community around modular smart glasses. And thank you very much.
Great, thank you so much. Excellent timing. And so I will pass the mic. You also reminded me that the captioning must have turned off when I switched sessions. So I turned it back on, so thank you. All right, and our next up this afternoon is from our physics and mathematics category, using mathematical models to predict infectious disease spread. I will pass the mic. Let me check.
All right, can you see my screen?
Yes, we can now. All right, you're good.
Hi, my name is Pranav Rao, and my project is using mathematical models to predict infectious disease spread. So pandemics have always had a major impact on our lives, so that's why it's important for us to be able to accurately be able to model the growth of these pandemics and also see how certain things that we can do can help greatly prevent the spread of this disease. So for my framework, what I did is I researched many models that people are using to model diseases, and I found out a model that I really liked, which is a SIR model. Although it was a very simple model, I liked the way it worked, but it didn't take in many things into consideration that are important. So I decided to make a variation of it and apply that variation to the COVID-19 pandemic. So I compared my model to the number of confirmed cases, and I analyzed how they differed and things that may have caused that difference. And I also tried changing certain variables in the model to see how certain things that we do can actually affect the spread of the disease, such as changing variables like R naught and N, which I use to represent the basic reproduction number, and the mixing parameter, so how much we quarantine infected individuals, and how if we change the patterns that we travel in can affect the spread of the disease. And I was able to find approximately how much changing these models would actually affect the total amount of cases. And some problems that I faced were that since there's not that much information on reinfections, I wasn't able to include it in the model. And I also
At 30
had,
seconds.
okay. And I also had could only compare my model to the confirmed cases. My model predicts the number of actual cases, not just the confirmed cases. So not all cases would be confirmed. But overall, it was pretty accurate, and I look forward to enjoy working more with it in the future. Thank you.
Wonderful. Thank you so much. And I will pass the mic. So our next project is the analysis of water quality and presence of microplastics and macroinvertebrates in the Little River. And with that, I will pass the mic.
All right, so my project was looking at the water quality in the Little River, specifically at two different sites along the river, one upstream in DuPont State Forest and another downstream next to a farm. So the two sites, we looked at three different ways to look at water quality. The first one was a chemical analysis of the water, including stuff like turbidity, nitrates, phosphates, and conductivity. And we found that we used to have sort of a control to make sure there wasn't any outside factors on the water quality that could change the quality of the river. And we found that there was no significant difference in the readings between the two sites, except for conductivity, which could indicate a higher presence of metals in the water downstream. The next thing we used was benthic macroinvertebrates for a biotic index score, which we used the SMIE method in order to determine. And we found there's a significant difference between the two sites with a lower water quality downstream than upstream. Finally, we used microplastics. We looked at microplastics. We took sediment samples in the river and we quantified the plastics from those samples in microplastics per gram of the sediment once dried. We found there was a significant difference between the two sites with a much higher presence of microplastics downstream than upstream. The difference actually had a p-value of 0.0025, which is extremely significant statistically. So one of the
30
main
seconds.
reasons we looked at benthic macroinvertebrates and microplastics is because benthic macroinvertebrates are benthic, meaning they live at the bottom of the river. So they would live in the sediment. That would be where they are. So they would be the closest affected by microplastic pollution. They also affect the entire ecosystem. They're the bottom of the food chain. They affect the river, but then they also, because a lot of them are insect larvae, they then go on to affect the forest and air.
All right, wonderful. Thank you so much. And with that, I will pass the microphone. And our next project up is designing a bioplastic material to replace polystyrene and polypropylene materials in single-use hard plastics. And this is a team project, so you ladies can decide how you want to share the mic.
Okay. So did you know that there are 40 billion pieces of plastic cutlery, which is forks, knives, and spoons, thrown away each year in the United States, which ends up in our landfills and waterways?
Isn't that terrible? Plastic cutlery is now one of the deadliest plastics for marine life. The only other alternative to plastic cutlery on the market today is a compostable cutlery made from PLA, which is a starch-based bioplastic.
However, that is not a good solution as it must be heated to 140 degrees Fahrenheit and exposed to special microbes in order to biodegrade. However, this rarely happens and it ends up alongside our plastic cutlery in our landfills and waterways.
So we decided to come up with a better alternative, one that would be healthier for us humans and one that would rapidly degrade in landfill, freshwater, and saltwater environments.
We made our bioplastic materials from gelatin, which is primarily a waste product. And we compare the strength of our materials to the strength of plastic materials of polystyrene and polypropylene. And we found that when dried, our materials were actually stronger than the plastic materials and would be good for making things like forks and knives.
However, when we exposed them to liquids for short periods of time, we found that they quickly lost their strength, so they wouldn't work well for things like spoons. So we started experimenting with adding things like agar and enzymes to increase their strength when exposed to liquids.
Agar comes from a red algae plant and is a vegan substitute for gelatin. The enzyme we used was called RM transglutaminase and is commonly used to hold meats together, like in fish sticks and chicken nuggets. And we found out by adding small amounts of the agar and the enzyme, it increased the strength of our bioplastic materials significantly, even when soaked in liquids, making them good for things like spoons. We tested the degradation of our bioplastics in landfill, freshwater, and saltwater environments, and all of our bioplastic materials completely degraded in under 30 days, making our bioplastic material a much better alternative to the compostable and the traditional plastic cutlery on the market today.
Wonderful. Thank you, ladies, so much.
Thank you.
Welcome. Yes. And I'll pass the mic. So up next, we have cytotoxic responses to the perfluorinated xenobiotic Gen X of ATP binding cassette protein and cellular activities in Crassostrea virginicea hemocytes. You're challenging me, Uma. Implications for global climate change. And you can teach me how to pronounce all of those words.
Yeah, you got almost everything right. It's Crassostrea virginica hemocytes, but you were really close.
Virginica hemocytes. Great, thank you.
Yep, I'll share my screen. All right, can everyone see it? Okay, awesome. So my name is Uma, and my project explored the inhibition of transport proteins and cellular functions in blood cells by Gen X, which is a perfluorinated contaminant that has been present in the Cape Fear River for 20 to 30 years now. So transport proteins are responsible for getting rid of toxins in cells, and especially in blood cells, we want to make sure that these proteins are working to the best of their ability so that these cells can function properly. In addition to exploring how Gen X was affecting these protein and cellular functions, I looked at how these effects were exacerbated by higher temperatures to mimic a warming environment by climate change. So in order to explore this, I looked at 4 different things. Mitochondrial membrane potential, which is the potential that the transport proteins have at removing those toxins by crossing the cell membrane. Cytotoxicity, so how much of those toxins are actually able to enter the cell. Reactive oxygen species production, which is a good measure of hypoxia or lack of oxygen, whether those cells are respirating enough, and viability. So are the cells dying when they're exposed to Gen X? What I found was decreased mitochondrial membrane potential with exposure to Gen X and further statistically significant decreases when that Gen X was combined with those higher temperatures. Found increased cytotoxicity and further increased cytotoxicity with Gen X plus the higher temperatures. I found increased reactive oxygen species production in cells exposed to the Gen X with even further increased reactive oxygen species production with when you combine Gen X with those higher temperatures. So Gen X is inducing hypoxia. While there were no significant effects on hemocyte viability, all of the other results from my experimentation point to Gen X is decreasing protein functionality, which makes those cells more susceptible to diseases like cancer. In addition to that, increased reactive oxygen species and increased hypoxia tends to favor the growth of tumor cells. All of these conclusions put together give us preliminary evidence that Gen X is a carcinogen. This is significant because the people in my hometown of Wilmington have been exposed to Gen X for 20 to 30 years now, and this research can help let them know what negative impacts Gen X is really having on their environment and their bodies.
Great, thank you so much. I forgot to tell you your 30-second warning, so I apologize, but you were on time.
Thank you so much.
Yes. All right, and I will pass the microphone. So next up, we have the construction of a fusion gene carrying E10A and K5 with 2A peptide linked by using overlap extension PCR. And with that, I'll pass the mic.
All right, I'm just gonna share my screen. So can you see it right now?
Yes.
Okay, so hello everyone. My name is Tian Lan, and I did my project construction of a fusion gene carrying E10A and K5 with 2A peptide link by using overlap extension PCR. So basically, since some cancers may have no response to normal therapies, such as surgery, radiotherapy, and chemotherapy, just like the liver cancer, and so it is very important to discover new methods of treating those cancers. And I found out the angiogenesis is considered as a critical process for tumor growing. And I further looked into those drugs that can have effective influence to the angiogenesis. So I found out the andostatin, which is ETNA, and the quingofide, which is K5, can inhibit the growth of tumors. Also, I wanted to link the andostatin and the quingofide together, so I used the 2A peptide, which can avoid many problems during the expression of more than one kind of protein. Also, in order to combine all the fragments together, I use the overlap extension PCR, which is a modern way to create a fusion gene. So basically, I first designed my primers from the SnapGene software, and then amplified with those fusion fragments, different fusion fragments, which include 4 fragments actually, and combine them together. And then I have kind of like my final product. And then I did the restriction enzyme digestion, and then the transfecting fusion gene into the HEC293E cells, so that my product can be expressed in the real cells.
30 seconds.
Then I did my results validation, so that I did the agroscale electrophoresis to do the validation of different fragments. And it turns out to be very, very good, because you can see there are just clear lines compared to the standard line. And then I also did the ELISA experiment to validate the concentration of the andostatin, and it turns out to be very great. Also, the gene sequencing proved that my final product expression is successfully. So I think that's my presentation, and my construction of the andostatin 2A peptide and quingofide is successful. Thank you for listening.
Thank you so much for sharing. I will take the mic, pass it over. Our next presentation is Saving Our Oceans One Field at a Time. With that, I'll pass it to Dakota.
Hey, so with my experiment, I decided that I wanted to do this because I want to be a marine biologist when I grow up. So my hypothesis was that changing our agricultural practices would help lower ocean acidification. So for my research, I conducted 2 experiments. The first experiment being the shell experiment. My hypothesis for this experiment was that more acidity would lead to more damage to a shell. I had 6 half clam shells in 6 cups. I had a variety of natural ocean water and acetic acid solutions. After 24 hours, I noticed that the shells in the more acidic solution started deteriorating, while the solutions with more salt water had minimal to no effects on the shell. I did this experiment again to further support the effects of ocean acidification that my hypothesis suggests. My next experiment that I did was the atmospheric CO2 experiment. And my hypothesis for this experiment was that more disturbance to the soil leads to higher CO2 emission levels. In testing this hypothesis, I tested the carbon dioxide levels of undisturbed and disturbed soil. While the soil was undisturbed, the carbon levels were low, around the 300-400 parts per million range. And then after I disturbed the soil, carbon levels doubled, and in some cases almost tripled. These 2 experiments were related because the extra carbon-2 emissions get absorbed into the ocean and turn into carbonic acid. It leads to ocean acidification, which is the decrease of pH of our oceans, and causes bleaching and loss of marine life.
Thank you for sharing.
Yeah.
Wonderful. All right, well, with that, Dakota was our final researcher to be on the schedule to present this afternoon, but I did want to revisit. We had a couple of researchers who could not make it earlier today, and I did not know if they were able to join. And so if anyone from this team is here and wants to present, I'm happy to give you your 2 minutes with a mic. I did not see you all in the participant list, but I just want to double check. Okay, there were 2 other teams. I had a scheduling problem. Is Jaden on? All right, one more, Joshua. Okay. Well, thank you all so much for your amazing research and for sharing it with us today. We do want you to know that you are now NCSEF alumni. Oops, sorry, that's my timer. You are now NCSEF SEF alumni, which if you were at any of the Spark Talks this morning, or if you visited our alumni corner, you know that we love to capture your stories as you grow and continue in your STEM careers. And so if you're interested in doing an alumni interview, I would love to talk to you. There is my contact information. And before we head out for the day, we hope you had an amazing Senior Division Fair Day. And we hope that you will join our live speaker events for the Junior and Senior Division. They are open to the public, so you are welcome to jump into Symposium and jump into any of those live events. They'll be the same structure. So we will have our Spark speakers on the morning of the 17th. This is Amari, Vivana, and Zane, and they are all from different regions of North Carolina and have all been student researchers in your shoes. And then we will have Anna and Lauren and Jack sharing with us on April 24th. This morning we had Jacqueline Howard, this afternoon at lunch, I guess, we had Jacqueline Howard, and she did some amazing Q&A and unpacked the supply chain for us and her career and all of the many career opportunities. And on the 17th, our lunch speaker will be Dr. Rachel Lance. So we hope that you can jump in at 11:30 that morning with us for Dr. Lance. She is going to join us from her high pressure lab and talk to us about unique types of injuries. Additionally, we want to make sure that you, our Senior Division participants, do join us tomorrow at 3 p.m. for our live awards ceremony. We are so excited to get the results in from the judges and to have you joining us for that live ceremony. It is one of our favorite parts of the fair, aside from hearing about all of your amazing research. And with that, we just ask you to keep in touch so that as we have new events, you don't miss out on any of the opportunities. We are on Twitter, Instagram, and Facebook. And so if you want to connect with us, that is how you can do that. And with that, we are ready to close our official competition day. We hope that you all had an amazing day and a great judging experience. And will be joining us tomorrow for the award ceremony, and we'll see you on the 17th and the 24th. I do love to hear your stories, so please do reach out to jump into an alumni interview with me. Thank you all so much, and congratulations on your accomplishments and your contributions to science and engineering.
I would like to say thank you as well, and I hate that I didn't get to hear you all, but looking forward to hearing about it in the future.